Okay, this next section, section 5.2, is actually going to be broken up into 3 different sections. So I am going to refer to this as 5.2a, okay? And really this one is talking about properties of rational exponents. Okay, properties of rational exponents. So I'm going to go ahead and draw. So if you remember when we were doing a review of exponents and all the rules of the exponents, I'm going to say the same thing again, like I said before. But remember that a lot of times we're dealing with exponents that have fractions. Okay, so I'm not going to divide my paper just yet because I'm going to put the rules at the top, and I might just do this. I actually might just divide my paper in half so that I will share with you the rule, and then over here I will give you an example. Okay, so one of the first rules that we want to talk about is if we have, and notice I'm going to use numbers here, but I could also use variables. So 8 to the 1/3, okay, times 8 to the 2/3 power. So right away, I know that that seems a little weird because I'm dealing with numbers, but what am I supposed to do with the exponents? That's right, I'm supposed to go ahead and add these. So what is 1/3 plus 2/3? Well, that's easy. You would tell me that's 3/3, or 8 to the first power, which is 8. Now see, I drew a line and I already went over it. Okay? No big thing. You add the exponents. Okay? So what do I do if I do a problem? So here we're going to do the examples over here, and we'll do the rules on this side. So what do I do if I do something like this? X to the 2/5 times x to the 4/3. Like something completely different. You might say, oh my gosh, Mrs. Bassett, those are 2 different fractions. Right. But they're the same variable. So this would be no different if I took out the bottoms and I just went 2 plus 4 is 6. So what is 2/5 plus 4/3? Friends, you have a calculator, okay? Use it. It's okay to put in on your calculator 2/5 plus 4/3 on your calculator. Sorry, I get to wave in my hands and my phone ends up going out. So it's okay to do that. You can add that together. I'm going to go old school, and because my calculator, I don't have batteries. So I'm going to go and do common denominator. So I get x is 26/15. Wow, that was really weird. But that's okay. It's all right being weird. Okay? So that's one of the first rules. So this is when I'm multiplying, I'm adding the exponents, aren't I? And let's write because of a common base. Notice that the 8 is the same. So what happens, so I'm going to put a star here. What happens if I do something like this? Okay, 5 to the 1/4 times 3 to the 1/4. Okay, well, you know what? Same power, but different bases. So can I just go ahead and add 1/4 plus 1/4? Well, no, because 5 and 3 aren't the same. Well, I do know that they're both to the 4th power. So I could rewrite this like this. Isn't that the same thing? 5 times 3 to the 1/4 power. And then at that point, I can do 15 to the 1/4 power and be done. Okay? Now, say for example, we had a problem like this. Let's do 5 to the 1/4 times 3 to the 1/2. Okay, friends, you know, the bases are not the same. The powers are not the same. This is simplified. I can't go any farther. Okay, if the bases aren't the same, the powers aren't the same, I really can't manipulate this any farther. We're talking totally different involvement here. Okay, so I'm going to draw a line, and that's going to kind of note to you that that was one of our rules that we had. Okay, so the next rule that we dealt with exponents was power to a power. Okay, so if we're thinking, let's do our 8 to the 1/3 to the second power. Well, that's easy. You told me earlier in class that all you have to do is 1/3 times 2, so this becomes 8 to the 2/3 power. Okay, what we do need to be aware of is how we can simplify if it's a number, how we can go ahead and simplify this and figure it out. So remember that I could go back and put this as a radical, and this would be the cube root of 8 squared. So the cube root of 8 is 2, and 2 squared is 4. So I can actually figure that out, especially when I say, hey, don't use a calculator. All right, let's do another one kind of like that. How about distributing power? So we did this when we practiced. How about 2x to the 1/3 power? Well, that's each piece needs to be taken to that 1/3 power. So 2 to the 1/3 and x to the 1/3. Done. Well, that was pretty easy. All right, so let's do something. Let's do an example over here. Okay, let's do an example. Let's do 5 to the 1/3, x to the 1/2, y to the 4th, to the 5/2 power. This will give us some good practice. So remember that I'm multiplying. So here's a power, here's a power, and here's a power. All right. So what is 5/2 times 1/3? Now, when you're multiplying fractions, you can do it on your calculator, but you need to leave the answer as a fraction. So just multiply the numerators. 1 times 5 is 5, and 3 times 2 is 6. Well, that was easy. I can look this up. Can I simplify it? Is the 6th root of 5 anything? No. All right, x. 1 times 5 is 5, and 2 times 2 is 4. Now, this is a whole number, so it's always over 1. So 4 times 5 is 20, and 1 times 2 is 2. Now, can I make that reduced? Sure, I can. So I can write this 5 to the 5/6, x to the 5/4, and y to the 10th. Okay. All right, let's do division. 8 to the 1/3 over 8 to the 2/3. We're actually going to do, I'm going to put 2 dots here because we're actually going to cover 2 concepts here. All right, so if I'm dividing, I want to subtract exponents. So this is like saying take 1/3 minus 2/3. Gives you 8 to the negative 1/3 power. Ooh, this now gets our second concept involved, and it is negative exponent. So where do we put this 8 to the 1/3 power? Well, that goes in to the basement because that's the inverse. We can't have negative powers. So I can go ahead and simplify this. What is the cube root of 8? Well, that's easy. That's 2. So my answer is 1/2. Okay. Let's do another one. Let's come over here and let's do this one. 4 to the x to the negative 2, I'm going to add a 2 up there. 2/3 power, okay? X. So I did 4x squared over x, okay? So one of the first things you might want to do is, I like to distribute things, but you could also subtract if you wanted. So you could take this and be like, oh, well, 2 minus 1, okay, is just an x. So it gets rid of the x on the bottom, okay? So it's like over 1. And now let's apply this power. So this would be 4 to the negative 2/3 and x to the negative 2/3. Well, yikes. I can't have negatives, so those need to both go down below. And now I'm done. Why am I done? I can't take the cube root of 4. Okay, so I know I can't do that. So not only did we distribute, but we also worked on subtracting, and we also worked on our negative exponents. And the last one, I didn't mention this, but I think it's important that we need to do that. If I take any number to the 0 power, I have 1, or x to the 0 power is a 1. So I think that's important to practice. So this is just the very beginning of this section. This kind of reiterates the properties. But remember that we're going to be dealing with a lot of fractional, so rational exponents. So don't forget to use your power table, okay? And usually the rule with this is that we want to stay fractions, and we also do not want no negative exponents, okay? So try not to do that either. All right, see you later.